Alright, so this next section we're going to be looking at how to solve equations, but we're going to have fractional exponents now. So how can we deal with that? So before we get too far into this, I want to just kind of go back over how the square root of x is equal to x to the 1/2. Also, when we have a power to a power, we end up multiplying the two together to get our new power. These are two ideas that are going to help us in our factoring and problems that we're going to do today. So let's start with our first example. This one's not going to have a fractional exponent, but I'm going to show you something with it that could help you with fractional exponents. So we've already kind of touched on this substitution idea, and so you could do something like this with a substitution, or you can just double bubble. It's kind of whichever one seems more doable for you. So if we just double bubble, x to the 4th is x squared times x squared, and then two things that multiply to 20 but add up to -9 would be -4 and -5. Then we can continue factoring if possible, because I notice I have a difference of squares here. So x plus 2 times x minus 2, and then this is just x squared minus 5. So now that we have it all broken down and factored, we can set each factor equal to 0 and solve for x. So we'll get -2, +2, and over here we have to remember when we square root both sides, we get plus minus the square root of 5. So we'll add 5 to both sides and then square root, not forgetting the plus minus. And those would be our 4 solutions. Now, if you wanted to do a substitution, you could say let u equal x squared. Let u equal, let u equal x squared, because then when you square u squared, you get x to the 4th. So you could substitute in u squared minus 9u plus 20 equals 0, factor, and you get u minus 5, u plus 5, minus 4 equals 0. So you have u is equal to 5 and u is equal to 4 after you set them equal. If you do it this way, you just have to remember at the end to go back and plug in what u was. So x squared equals 5, so when we solve that, we get plus minus root 5, so we get the same answer. Over here, we'll get x squared equals 4, so when we square root, again, don't forget the plus minus, we get plus minus 2. So we get the same answers, it's just a different way to go about it. Now, the substitution idea for something like an x to the 4th might not seem necessary, but sometimes when we have fractional exponents, it actually can make it easier to do the substitution idea. You don't have to, but it can make it easier. Okay, so I'm going to do one more like this, where we have an x to the 4th. So what you might want to notice on this one is that it doesn't equal 0 yet. And so when we do any of these, we have to get it equal to 0 before we can really start solving our polynomial. So I'm going to subtract 21 to both sides. So now I have something that I can start off and factor with. So again, x to the 4th, I'm going to go ahead and just double bubble it. So two things that multiply to -21 and add up to -4 would be -7 and 3. Neither of those factor further. So I'm going to go ahead and set each one equal to 0 so I can solve. So x squared equals 7, x would equal plus minus square root 7. And then over here we'll get x squared equals -3. Well, what can we have something being squared or square rooted? Can we square root a negative number? No, so this is not a solution. So if you get something here, we're only dealing with real numbers, not imaginary. So we're going to go ahead and say square root of negatives are not real solutions, because they're not, and you're just going to cross it off. We are going to get a little later on in the year into the imaginary solutions as well as the real. For right now, we're just looking at the real solutions, so there should be no imaginary numbers in our answers. So if this happens, you just cross it off. You don't have to worry about keeping it as a part of your solutions. You're just going to do the two positive ones. All right, so let's get into some fractional exponents. So this next one will definitely have some fractional exponents. You do have a test question like this, so you can star it, highlight it, do something so that you know this is one you need to know how to do. So when I look at this, again, I see both ways. If you don't like substitution, you just have to be really good with how your fractions multiply to get your exponents. If you do like substitution, this would be a good one to do. So one of the things that I notice is that if I were to do 1/2 squared, actually, let me rewrite that so it makes more sense. Right now, if we look at our first term here, that's what I'm looking at. I have my parentheses to the 1/2. Well, if I were to do a parentheses to the 1/4 and square that, I would get a parentheses to the 1/2. So one of the things with fractional exponents that you want to remember is that when you multiply these, so if you had 1/4 squared, you get 1/2. So that's kind of showing us that this here is a squared term, this is a linear term, and this is our constant term. So what you can do is take something to the 1/4, and if you square it, you'll get something to the 1/2. So if you're going to do this substitution, I would call this u, and knowing that when I square a 1/4, I get a 1/2, I can call this u squared. So if I plug in every other coefficient, I'm left with this polynomial. Again, if you would rather just keep it as double bubble, your first bubble would have a parentheses x minus 2 to the 1/4, and your second bubble will have an x minus 2 to the 1/4 in the starting position. If that gets confusing, because sometimes it might when you have all these parentheses and fractional exponents, this is where this u substitution can come into play to help you a lot with simplifying your factoring. So because I noticed that 1/4 squared will give me 1/2, I can do my substitution with this being u and this being u squared. That leaves me with a much simpler polynomial in which to factor and solve. So when I factor, I get u plus 5, u minus 2. And so when I solve it, I'll get u is equal to -5 and u is equal to 2. Now, just like in the one I showed you at the very beginning, you want to make sure that at the end you go back to your original variable. So we had said u was equal to x minus 2 to the 1/4. So I'm going to have x minus 2 to the 1/4 equals -5, and x minus 2 to the 1/4 equals 2. So if we think about what this means we're doing a 4th root and getting a negative. Any even root can never equal a negative, because if we rewrite this as the 4th root of x minus 2 is equal to a negative number, that's not possible, so we can cross that out. Over here, again, we have a 4th root, so to undo a 4th root, you raise both sides to the 4th power. So we end up with x minus 2, because 4 times 1/4 will give me a 1 exponent. 2 to the 4th will give me 16, add 2 to both sides, and I get 18 as my answer. So again, just to kind of recap how we did this, we started with x minus 2 to the 1/4, and then we set that as u. When we squared that, we get x minus 2 to the 1/2, which becomes our u squared. And then we'll go through, factor our simplified substituted polynomial, get our u values, and then from there we have to go plug back in what our u was, so that way we can solve for x. Okay, this might be a weird idea, so please mark any questions that you have, and we're going to go over them in class. Plus, in class, I'm going to add one more example before we start our problem set, dealing with how to do a negative exponent in the same way as we just did these positives. So go ahead and make sure you note any questions, you rewatch for whatever you need to rewatch. And again, we're going to add one more example to this in class tomorrow before we start our assignment.